Hello, my name is Juan Morilla. In the following 10 minutes, I will explain what a smart grid is. Based on the paper Smart Grids in China, written by Yi Haiyuan, Jia Kunshen, Li Pang, Shannon Shao, and Jungji Kang from the North China School of Economics and Business, and also from the State Nuclear Energy Program. As is well as known, China is a people republic governed by the Chinese Communist Party. The country is under heavy censorship regarding its technology developments. However, the article reviews how smart energy grids can be integrated into the nation's power grid in order to optimize its resources. China is a pioneer in the development of smart grids, with private companies developing their own technologies due to the high market demand, especially in ultra-high power applications. However, in aspects such as generation, distribution, microgrids, and demand management, the development has been slower and more limited. The generation of energy through smart grids is a way to contribute to the country's low carbon-based system. Within the paper, three main ways are highlighted. First, smart grids are able to improve energy efficiency by improving the performance of traditional power plants and power grids. Second, smart grids facilitate the integration of renewable energy power, either on a very large scale of distribution and or small scale. Third, smart grids can power innovation as the demand for electric power continues to increase. Since 2009, following the announcement of the Minister of Science and Technology in China, a research and development program has been developed regarding smart grids, which results in the first quarter of 2012, smart grids were added to China's energy system, improving the supply rates and improving the power system. Also, thanks to the joint development of two companies in the country, a private company known as State Grid Corporation of China, SGCC, and the Ministry of Science and Technology, MUST. Within this development, the budget allocated for the construction of smart power grids increased to 36 to 45%. However, remaining below the international standard of 60%, which generates certain inconvenience, especially considering the distribution of China electricity systems. The production is generated mainly in the north and west of the country, while the greatest demand occurs in the center and east of the Asian giant. This results in a transmission distance of more than 2,000 kilometers, insufficient networks, low distribution power levels, and poor demand management. SGCC's perspective on smart grids therefore focused on a type of automatic power grids capable of supporting ultra-high voltage USB to improve power transmission. This is a completely different perspective from what is being developed throughout the world. For example, in Europe, the United States, and Russia, the USB grid strategy is practically abandoned, as these countries focus more on customer service, seeking access and adequate distribution of renewable energies, locating the load and power needed by the customer, and finally ensuring energy efficiency that is safe and reliable. In the table 1, we can see the stakeholders of smart grids. First, the central government, solving the energy puzzle from the smart grids, revitalizing the electricity system and creating a new industry around it. The local government, adequate energy distribution according to the local demand. Equipment manufacturers establishing the technology standard as soon as possible. Grid companies, this is so much money for this. Power consumed, we can access stable power supply, cost efficient of power supply. And this is the main part of the Table 1. In Table 2, we can compare the smart grids with traditional grids. First, the operational efficiency is basically an intelligent network seeks to prevent accidents, providing the end user with safety and efficiency, which itself is an operational advantage for the company in charge. With the operation of an smart grid, constant monitoring of the resource and equipment involved is allowed, clearly reducing maintenance and repair costs. Related to the above, by having sensors and constant feedback, it is possible to detect anomalies early, which allows correcting such errors before they become dangerous and costly problems. With smart grids, security is greatly improved against external attacks that may hinder the network. Focusing now on important aspects to develop smart grids in China, we have aspects as power generation requires, for example, coordination between regular power plants with smart grids. Adequate control is required for renewable energies, which likewise require adequate storage and technology to avoid losses. For transmission, a GPS positioning is so much important. It's needed to allow real-time monitoring and inspection related to the above software capable of allowing accurate analysis of the given feedback. It's required to prevent accidents. At this point in the transformation, a parenthesis should be made to illustrate to the people watching this video about the DC-DC converters using in smart grids. This is the solid-state transformer, and SST for its acronym in English, that is considered the heart of smart grids, as it has bidirectional flow, a fundamental part of the integration for renewable energy within conventional power grids. Therefore, a proper operation of this ensures proper operation of smart grids. To have a DC-DC operation, it is necessary to talk about a dual-active bridge converter, DAB, which has an essential feature within the SST and is the zero switching voltage. This allows a change of direction in the current, ideally without loss. However, in the current reality presents smart RMS voltage leakage. In the image, you can see how inside a solid transformer based on transmission operation, the dual-active bridge is essentially a controlled single-phase rectifier operated as an inverter and rectifier, hence it's bidirectional. In conclusion, a transformer fulfills the functions of isolation, load protection against disturbance, compensation, and very protection for the load. Continuing and returning to our paper, we will delve a little into key aspects and their progress in the country. First, large-scale wind power generation, where an integration plan could be developed for power values between 3 and 10 gigawatts. National projects will also development hand in hand with a specialized institution with wind and solar energy capable of being integrated into the conventional power grid with smart grids. In terms of transmission, it was crucial for the country to implement HVDC type grids together with transmission lines that were easier to monitor and guaranteed the flow of electricity all the time. The corridor was effectively implemented thanks to the work of the SGCC together with the Chinese Academy of Science since 2011. Finally, for transformation, 1,000 substations with conventional transformers were replaced by the aforementioned solid-state transformer (SST), contributing to an advance in the intelligence and maintenance of substations throughout the country. In conclusion, and after analyzing the information presented, China has present great advance in terms of intelligent networks, being a pioneer country in the far east, developing ultra-high voltage networks and renewing its substations. However, it's noteworthy that the development in microgrids and the management of energy distribution progress is slow and limited. The research revealed a lack of a clear national strategy, so that all companies in the industry can follow the same path to achieve adequate development. China should undoubtedly promote the electricity sector, strong focus on smart grid in order to envision a bright future for the Asian country power grids.